Hello, good morning. Today, organic synthesis, retrosynthetic analysis by disconnection approach. In this context, first of all, synthesis. Synthesis, a process of preparing a compound from its elements or other compounds. Target molecule, it is represented by TM. The required product molecule, the molecule to be synthesized is the target molecule. Synthesis is the process of preparing the compound from its elements or other compounds. Organic synthesis, retrosynthesis, analyzed by the disconnection approach. Organic synthesis is a special branch of chemical synthesis, and it is the concern with construction of organic compounds via organic reaction. Organic synthesis is the special branch of the chemical synthesis, and it is concerned with construction of organic compounds via organic reactions. Gradual development of organic synthesis. In the middle of 19th field of the base catalyzed reaction. In the 19th, better understand atomic structure and understand mechanism, bond breaking and bond making by chemists. 20th, landmark synthesis. Example, Wolff's synthesis of camphor, Perkins alpha-terminol 1904, Robson's atropine 1917, Fischer amine 1927, Volkser pyroxide 1939, Woodward's quinone 1944. After 1950, synthetic organic chemistry showed an accelerating growth because of the following developments. Organic reaction mechanisms were better understood. Stereochemistry and conformation of the molecules understood. Spectroscopic methods were developed to identify organic molecules. Chromatographic techniques were developed to purify organic compounds. Many chemo, regio, and stereoselectives. Selection depends on chemicals, regions, and stereochemistry of reagents and catalysts had been developed. Organic reaction mechanisms were better understood. Stereochemistry and conformation of the molecules understood. Spectroscopic methods were developed to identify organic molecules. Chromatographic techniques were developed to purify organic compounds. Many chemoregio and stereoselect reagents have been developed. The chemists could select the right starting materials mostly by trial and error method and guided by the individual genius skillful. If one starting material fell, the anode was selected. The selection of the starting material was the key to the success of all the above okay. The selection of starting material was the key to the success of all the above mentioned synthesis. Since 1970, a new thought come into the field of organic synthesis, mainly due to wizard of synthesis, organic chemist Corey. This approach is known as the retrosynthesis or anti-synthesis. Okay, retrosynthesis. Retrosynthesis, this is the concept developed by E.G. Corey, and we define retrosynthetic analysis as a problem-solving techniques for transforming the structure of the synthetic target molecule to a sequence of progressively simpler or commercially available starting material for chemical synthesis. See, for example, this is the target molecule. These are the logical disconnection syntones. Synthetic routes, the process of converting the starting molecules into required product molecule is the synthetic route. Retrosynthesis, the exact reverse of the actual synthesis, we can also discuss in this way. The construction of synthetic pathway of the backward from the target molecule is called retrosynthetic symbol, which signifies a reverse synthetic step, is called the transform. In a reverse synthesis or retrosynthesis, the construction of a synthetic pathway by working the backward from the target molecule is called retrosynthesis. This helps chemists to design synthesis. The symbol signifies a reverse synthetic step and is called a transform. In a reverse synthesis or retrosynthetic analysis, we move from target molecule to synthones and further to synthetic equivalents. See, this target molecule transform into synthones and synthones from the synthetic equivalents. Okay, retrosynthesis target molecule. These terms used functional group interconversion or interchange, SE synthetic equivalence, IP inverting the polarity or umpolum. Target molecule transforms synthones, synthetic equivalent or reagents. Symbols of retrosynthetic analysis or disconnection is represented by wavy line through the bone being disconnected. A retrosynthetic arrow, this is the open arrow, represents going from the target molecule backward to the simpler molecules. A synthetic arrow, okay, synthetic arrow, this is closed arrow, represent going in forward direction from the reagent or synthetic equivalence to the target molecule. This arrow denotes the backwards, that is the target molecule to the synthone, and that is the synthetic equivalence. This is the breakdown or disconnection. For example, disconnection from here, retrosynthetic step. In this case, it is the synthesizing. This is the disconnection. This is the condensation. In here, this is the disconnection, retrosynthetic arrow, synthetic arrow. Disconnection, retrosynthesis, synthesis. Okay, retrons, the key structural subunit of target molecule that represents the minimum enabling element for the transform to operate is called retrons. For example, cyclohexene dilalars transform. These are retrons. Transform, it is a process of function for the transformation of a molecule to a synthetic precursor. Okay, transform is the process of function for the transformation of molecule to the synthetic precursor. It is exact reverse of the synthetic reactions. Thus, transform can be defined as the synthetic operation or process for transformation of molecule to its synthetic precursor. In the reverse way, example, dialysol transform. See, in retrons, cyclohexene transform produce retrons. In the transform, retrons into cyclohexene. Transform is also defined exact reverse of synthetic reaction, the formation of starting material from the single form. C. Acetophenone. These are the syntones. In the retrosynthesis analysis, the target molecule is available starting molecule by disconnection of bonds groups. Every disconnection gives the fragments will be the cation, anion, radical, or axial reagent. And these fragments are called syntones. So idealized fragments which are obtained by molecular disconnection is called syntones. The idealized fragment which are obtained by the molecular disconnection is called syntones. C. Phenyl acetic acid. These are the syntones. And syntones can be easily available, can be obtained in the market. That is the synthetic equivalents. Alcohol, these are syntones. Disconnection. A syntone is idealized fragment species generated from a bond disconnection during the retrosynthesis. It may not necessarily correspond to a real molecule. Synthetic equivalent is a molecule or reagent that can ascribe to a syntone and can be employed in a synthetic step. Okay, syntone is the idealized fragment species generated from a bond disconnection during retrosynthetic analysis. It may not necessarily correspond to a real molecule. A synthetic equivalent is a real molecule or reagent that can be ascribed to a syntone and can be employed in a synthetic step. See, these are the syntones. Or syntones are those chemical fragments obtained from the disconnection of the bonds of the target molecule. Or syntones and their synthetic equivalents. Common acceptor syntones, and these are the synthetic equivalents. Alkyl, aryl, acylium ion. Oxocarbenium ion. Common donor syntones, cyanide, alkyl, acid stylites. Synthetic equivalence. Synthetic equivalence is a reagent that carries out the function of syntone. Syntones are reacted with the corresponding synthetic equivalent to obtain the desired target molecule. For example, synthetic equivalent of carboxylic group in the synthesis of phenylacetic acid is. Synthetic equivalents are the chemical species which is used to generate syntones. They are actual substrate, the forward reaction, and hence forward synthesis. Also, synthetic equivalents are the reagent derived from starting polarity of syntones. Corresponding syntones are reacted to produce desired product. In this case, cyanide is synthetic equivalent for carboxylic and benzyl bromide, synthetic equivalent for benzyl syntone. Phenylacetic acid, logical disconnection, synthetic equivalence. These are the synthetic equivalents. Donor syntones, acceptor syntones. disconnection. An analytical operation which breaks a bond and converts a molecule into a possible starting materials during the retrosynthetic analysis. The reverse of the chemical reaction and a symbol is a chord line to the bond being broken. Target molecule. The molecule whose synthesis is being planned. It is also called desired final product molecule. This is the final product molecule, the target molecule. Functional group interconversion. Changing one functional group into another is defined as the functional group interconversion FGI. See, there's the bromine. It is interconverted into alkene. Alcohol converted into ketone. Okay, many functional groups can be interconverted into each other. Example, oxidation of alcohol gives an aldehyde and further oxidation gives carboxylic acid. Many organic transformation can be used to functional group interconversion. Carbonyl groups are particularly useful in this respect. The reactivity of the carbonyl group can be maxed during the synthesis and double bond ozonolysis for functional group interconversion to aldehyde for dioxylane until needed. Functional group integration describes a process of converting one functional group into another. Example, in alcohol and aldehyde, alkyne to alkene. Although functional group interconversion does not offer much gain to synthesis, it is the stage subsequent disconnection of the intermediate. Retrosynthetic analysis of the muscular to identify the disconnection and functional group interconversions. This is a general example, musculature, oxidation, functional group interconversion. C, that is the alkene and alkyne disconnected. Disconnected from here and again disconnection. Inverting polarity oblong of polarity inversion of organic chemistry is the chemical modification of functional group with the aim of the reversal of polarity of that group. The modification allows secondary reaction of this functional group that would otherwise not be possible. The concept was introduced by D.Sc and Izikori. Polarity analysis during the retrosynthesis analysis tells a chemist when oblong tactics are required to synthesize a target molecule. Inverting the polarity or polarity inversion in the organic chemistry or ampulam. Polarity inversion in organic chemistry is a chemical modification of functional group with the aim of the reversal polarity of the group. Reagent. A compound which reacts to give the intermediate in the plant synthesis or give the target molecule itself. It is the synthetic equivalent of the synthon. Acid, lithium aluminum 4, methyl magnesium bride, CH2 phenyl, NBS bromine, N bromosuccinimide. Synthon equivalent, a reagent carrying out the function of a synthon which cannot itself be used. Synthetic planning. Synthesis is the construction process that involves the converting simple or commercially available molecule into complex molecules using specific reagent associated with the known reaction in the retrosynthetic scheme. Oxidation, alcohol, specific reagent, aldehyde, pyridinium, chlorochromate. Strategy in retrosynthesis. For making the strategy in retrosynthesis, different possibilities have to be worked out. The following number of disconnection and functional group interconversion based on basic knowledge of the basic organic chemistry. There are two types of the possible. Conversion, linear synthesis, convergent synthesis. Synthesis which is prepared and then assembled. Difference between syntone and synthetic equivalent. Syntone is the moiety of chemical compound which can be formed by non-synthetic process. Synthetic equivalent. Synthetic equivalent is the reagent that carries out the function of the syntone, which is commercially available. A part of substrate molecule whose structure will be changed into order obtain desired structure, the molecule that should react with the syntone in order to get desired compound. Syntone for the production of phenylacetic acid or carboxylic acid group. Synthetic equivalence for carboxylic acid group is production of phenylacetic acid. Symbol double line arrow implies the reverse chemical reaction, usually functional group interchange, functional group addition, dissociation, disconnection, target molecule precursor fragments. Syntone or synthesized fragment usually ion produce disconnection, synthetic equivalence. Functional group interconversion, the process of converting the functional group into another substitution, addition, elimination, oxidation reaction. Changing one functional group into another is defined as the functional group interchange. Functional group addition, the process of addition of functional group in place of hydrogen in a hydrocarbon before disconnection, called functional group addition. Benzene introduction of some functional group is difficult, then functional group addition is done, benzening, and subsequently that is converted into desired functional group. Retrosynthetic analysis, consider the retrosynthetic analysis of musculature, to illustrate concept of retrosynthetic analysis. This is the muscular partial hydrogenation, alkylation, this breakdown, alkylation, starting material. The retrosynthetic analysis of any molecule must be based on known chemical reaction for its standard realistic translated in chemical synthesis. Synthetic planning, when evaluating the various retrosynthetic scheme of the target molecule, it is important to recognize the strategic feature of the molecule that synthesis must be addressed. Consider the chemical synthesis of muscular to appreciate how the two retrosynthetic plants fit in, but most of the importantly note, use the specific reagent that transform the intermediates in retrosynthetic scheme eventually to the target molecule. Acetylene, Retrosynthetic analysis and synthetic planning requires the training, knowledge of chemistry, and experience practical application of chemistry. The wider someone knowledgeable is organic chemistry, the more the options available to one to develop a variety of synthetic routes to a target molecule. One of these retrosynthetic pathways may turn out to be more practical and executable than the others. A good synthetic plan should be considered taking into account the advantage of convergent synthesis is possible over linear synthesis. Target molecule, functional group interchange, disconnection, syntone, acceptor syntone, synthetic equivalent donor syntone, synthesis. Grignard reagent, alkyl halide, reconnection, functional group interchange, target molecule. Retrosynthesis 2 is the energy example. Okay. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for the patience. It's now bye bye. See you again.